This is my new coordinates x dash y dash, which I define as a cos phi x minus y tan phi cos phi y plus x tan phi. Now here we are taking slightly a liberty, okay, where if I consider actual rotation, an actual rotation is like this, okay, which is I am considering is equivalent to your this rotation. So anyhow, this is my x dash and y dash. Now here, if you observe that, still there is a multiplication which is required. If I want to find out new axis x dash and y dash, then there is a multiplication and then there is a trigonometric term. Okay. So still this equation is difficult to implement. Now we will try to adopt some assumption over here. Okay. And that assumption is proven that that is a valid one. Okay. Now what we are trying to do? We are trying to consider this tan phi or tan alpha I is equal to 2 raised to minus I. Okay. Now what we are trying to get it is, now this actually I am considering that this whatever the angle, this angle is nothing but of 2 raised to minus I. Okay. Now how you can actually find it out that you can take a simple value of the different tan phi and then try to find out the different value. Okay. Now if I consider tan 0, what is tan 0? 0. Tan 0 is 0. Okay. So if I put it, let's say I am talking about tan 45. What is tan 45? Tan 45 is 1. Okay. So if you try to plug different values and try to consider assume that this is tan alpha, I am considering only in 2 raised to I form. Now why this assumption we are considering? We want to avoid multiplication. If you remember, when we talk about our arithmetic, at that time also we discussed that division is you can consider the most complex arithmetic operation. Multiplication is slightly you can consider below than the division. Then comes the subtraction and lastly addition. Addition is the simplest one. Okay. Now somehow, if any of these operator we can go away with, then it would definitely help us to simplify our arithmetic. So what we are trying to do? We are just considering this is a 2 raised to minus I form. Okay. And now this tan alpha I we are considering is a actually when we want to calculate one particular angle, then this angle I am considering as a I, alpha I. Now here we are considering some tabulation. Okay, we are preparing one table which we consider as a standard one. Now if you consider when I put alpha I is equal to 0, okay, when I put I is equal to 0, then it is 2 raised to 0, that is 1. So that I know that alpha I is 45. We just mentioned that tan 45 is 1. Okay. Now similarly, I put I equal to 1. So 2 raised to minus 1, that is 1 by 2. So 1 by 2 is nothing but that is alpha value is 26.6. Okay. Similarly, I put 2. So this way I am writing a different I value and depending upon that this alpha value of 10 I am calculating. Okay. And this I have put as a standard table. So this is nothing but this one is of 10 alpha 1. So for that alpha is equal to 45. Similarly 26.6 is 0.5. Similarly 1014 is 0.25, which actually a 2 raised to minus 0, 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, 2 raised to minus 4, like that. It may happen that some of the value may not be exactly, but we can have an approximate. Okay, if 10, let's say 10 1.8 value is 0.03125, but if it is 0.032 something, then also I will take a liberty to just consider it is equal to, just to ensure that it will be 2 raised to minus 4. Okay, so according to that, I am just considering this value. The intention is clear. Why I am trying to do that? Because this, if it becomes 2 raised to minus I form, then I can do a simply rotation. Because 2 raised to minus I is simply a rotation of my left. No, right. Rotation of that on right. So if I rotate on a right hand side, then it will be simply a division, which is of 2 raised to minus I. Okay. So this way I am preparing a standard value. Now, if my any alpha value, suppose that I am interested to measure a some value of 10, but that is not directly which is applicable inside this particular table. Let's say that I am interested in 10, 20. That angle is 20. So how I can identify? Now 10 T is not here. Because 10, 20 is ultimately, it is not form of 2 raised to minus I. Okay. So at that time, how I can calculate? So at that time, what I will try to do, I will find out that particular alpha, which could be a summation of this all alpha. So I am defining this as a alpha 0, this as a alpha 1, this as a alpha 2, like this as a alpha 9. Okay. So if I am interested to any 5, which is not, with the angle value is not from this particular table, then I am considering that this is equivalent to your alpha 0 plus or minus alpha 1 plus or minus alpha 2, like that. Here I have shown up to alpha 9. Okay, but you can even increase this. You can put I equal to 10 and then find out the alpha I value equivalent. Okay, so there is no problem. But what I am trying to figure out, that whatever the alpha that I want to calculate, whatever the angle that I want to calculate, that angle is in some form of alpha. So that means that if I want to find out the 20 value, then I can think about that 45 initially minus 26. So if I do it, then 19, then plus alpha 2, like that. Now, ultimately this alpha value which I need to consider, that has to be strictly in this order. Okay, that means alpha 0 is constant, alpha 1 is constant, alpha 2 is constant. Okay, so that value seems to be constant, but whatever the angle I want to find it out, that has to be some summation of this, and with that I need to find out in how many iterations I can get the approximation. Okay, so this, just to give you the example, let's consider angle 30 I am interested to calculate. Now angle 30 is not in this particular table. Okay, however 1030 maybe you might be knowing. Okay, but this, just to give you the example I am explaining, but it could be 20 also, it could be 35 also, it could be 60, it could be 70. Any angle which is in between 0 to 90, that I am considering. Okay, any angle which is beyond 90, for that always I can consider 90 plus that value. If I am interested in a 120, then also you can consider that I will follow the steps for 30 and then I will write down 90 plus 30, and this way I can calculate the solution. So let's consider that I am interested in angle 30, which is not the conventional value which is there in the table. So how I can get it? So that means this is has to be some linear combination of my alpha. That is alpha 0 plus or minus alpha 1 plus or minus alpha 2, like that. Okay. Now how I can do it? Now initially I will always start with x-axis. That means from 1 0. Why I am starting? Because that initial value of x and y is known to me. See, if I start with any point of time, then ultimately I am aware about that what is this xy value. But why I am starting with the x-axis? Because for a x-axis, I know the value. As since we are talking about the unit circle, so definitely this particular point which I am talking about, that is part of that unit circle. So that is having a axis value 1 0. Now from this 1 0, I am trying to rotate it. Now rotation, for that you need to consider this rotation will be always following this fixed alpha. That means first it will come 45, then it will come 26.6, then 14, then 7.1, 3.6, like that. Now you can always strictly follow this particular way. Now you cannot go from 45 to 3. Maybe you can consider that 30. So 30 is 45 minus 14. Then I can go to the 30 near to. It is not like this case. Since we are talking about the lookup table, okay, so lookup table you can consider it is something like a memory. Okay, so in this memory, I always follow address one by one. That means this is being stored, let's say at location 0, this is at 1, 2, 3, like that. So serially I am accessing each and every value, and that I am using it for a linear combination of my alpha. So that means that I am interested in 30. So now with this is the linear combination of some alpha. So how I can get it? So initially I am starting with alpha. Alpha 0 is always 45. That we have just observed. Okay. Now this is greater than 30. So as this is greater than 30, so what I can do? Why this 30 is important? This is my actual angle. So if 45, which is my alpha 0, is greater than whatever I am looking for, then next alpha is always I need to subtract. What you need to consider, just try to understand with this. This is 30 where I am interested. So if I actually talk about alpha 0, then actually I am beyond this point. That means I am towards 90. But ultimately I need to move towards 0 now. I am considering this as a 0, this as a 90. So when I consider my first alpha 0, which is my first obvious value of my lookup table, so that alpha 0 is my 45. So 45 is actually greater than 30. So now next alpha 1, which I need to choose. What is alpha 1? Alpha 1 is standard 26.6. So that has to be subtracted from 45. Now this 5 is ultimately linear combination of my alpha. Alpha 0 plus or minus alpha 1 plus or minus alpha 2. Okay. Now since we are talking about the first quarter, so always this alpha 0 is positive. This alpha 0 is always positive. Okay. But from second alpha, alpha 1, alpha 2, alpha 3, it could be negative or it could be positive. That means here there is a possibility that alpha 0 plus alpha 1, or there is a possibility that alpha 0 minus alpha 1. So that means before alpha 1, there could be positive or negative. It depends upon which angle you are looking for. Okay. Now here I am looking for 30. So that's why if alpha 0 is 45, I am considering that 45 is greater than 30. So if it is greater than, then I need to subtract my next angle. Okay. Now if this angle, let's consider it is 65. Then 65 is greater than 45. So that time, whatever this alpha 1, this is standard alpha 1 value, that has to be added on 45. Because I need to get closer to my desired angle. Now, if I add anything on alpha 0, then this will go beyond this. So that means I am moving away from whatever is required at this point. Okay. So for that, what simple logic I am getting? That I am always looking at where I am and what is my actual desired point. So my desired angle is 30 and currently I am 45. So I am subtracting 45 minus 30. If that subtraction value is positive, that means it happens only when this 45 is greater than your 30. So at that time, if your angle value is positive, then next alpha value is always negative. So now this alpha 1, this is alpha 1. So I am considering this 45 minus 26, so which will give me 18. Now this 18, if I compare with this, so 18 minus 30, this gives me a negative difference. So this gives me that whatever my alpha 2 is always this value, 14. So this has to be added with this value. Okay. So what I am trying to do, I am considering starting with positive alpha, then I am doing minus alpha 1 to ensure that I will be nearer to 30. Then second one, I am considering alpha 2. Now this sign of the alpha is being derived by this difference. Okay. Initially, the difference was positive. The difference of what? Difference of whatever my present alpha minus whatever the angle which I am looking. So 45 minus 30, positive value. So that gives me that next value is minus. So that is minus alpha. Now, again I am getting 18. Now 18. So if I subtract further from 18, then it will go nearer to 0. But where I need to move? I need to move to 30. So that means anything angle which I need to add in my 18 now, so that I can move towards the 30. So that's why after this, what will be the next value? I am just rubbing it. So what will be my next value? So this is 30. Now this is my actually for a 26.6. Now 26.6 I will add again. So this I will add alpha 2. So it will move to somewhere over here, which is slightly greater than this is 32.4. So 18.4, next I have added the alpha, which gives me 32.4. Now 32.4 is again beyond my 30. So that means now I need to subtract next alpha value. So next alpha value is minus 7.5. Now I will 25.5. But 25.3 is lesser than 30. So now whatever the next alpha I need to add to get closer to 30. So 3.6, 28.9. 28.9 is lesser than 30. So that means I need to do addition. So here it is two subsequent addition will be there. So that I will get 30.7. Now this 30.7 is nearer to 30. But still, if you want to improve, then ultimately next angle you need to subtract. What is your next angle? It is 0.9. Okay. Then 0.4. So ultimately your next angle will be minus 0.9. That's 0.9 will give you 29.8. Maybe I am getting closer. If you want to still go to closer, then next value is 0.4, which I can add. So that is 30.2. Next angle is minus 0.2, which I can subtract. So which I get is exactly 30. So now I am getting the exactly 30 value. Any particular angle, if I am interested, I can calculate, which is the linear combination of alpha. Now, whether the alpha is plus, always alpha 0 is positive. Alpha 0 is always positive. But from second alpha, that is alpha 1, you need to either add or subtract. Now, for that, you need to just apply a simple logic that I need to go to the nearer to whatever I am looking for. And according to that you need to decide that whether I need to go for alpha 0 or alpha 1. Or in simple case, if I want to apply some logic, then ultimately I am taking a difference of my present alpha value with the angle which is desired. So with that, if the difference is positive, next alpha will be negative. And if this difference is negative, then next alpha will be positive. Okay. Now, देयर मे बी ए क्वेश्चन कि सर अगर मुझे जाना है 30 पे तो 45 से डायरेक्ट जंप कर 40 पे आ जाता हूं और फिर उससे यहां पे जंप करके -1.8 ले लेता हूं. ओके, सो दैट ऑफ कोर्स seems to be a clever technique. Okay, but consider that then at that time you should have some sort of axis of member or random location of this memory. Always in a memory, a randomly accessing a address would be a difficult one. So that means you need to now create a one particular hardware which could allow you to have a random access of the memory. But here you do not have to worry about it because always it will be incremented to a next level. It is simple case. माइक्रोप्रोसेसर में क्या प्रोग्राम काउंटर हर बार नेक्स्ट इंस्ट्रक्शन पे एड्रेस लोकेशन पे जाता है. तो सिमिलरली ये भी मेमोरी लोकेशन में नेक्स्ट लोकेशन पे ऑटोमेटिकली जाता है. Over there you do not have to actually develop any logic. Okay, of course the clever technique could be applied where I can get in a lesser number of iterations, because over here probably after 8 iteration I am getting exactly 30 value, but maybe with the random you can get it more closer. But at that time whatever the hardware is required or whatever the complexity which is being involved to randomly accessing the memory, it would be more than actually you just do it by simple this sequentially. Okay, so that has been observed, and with that they have identified that you need to go with this particular angle always in a serial manner. That means after 45 the next angle value is 26. Now whether 26 you need to add or subtract, of course that is in your hand, but you cannot go from 45 to 14 or any lower value. Always this angle has to be comes at in a serial order. So with this you can find out that any desired angle would be fit in some sort of combination of this alpha, and with that you can find out the any value of my angle. ठीक है, so I can solve any trigonometric function with that particular. Now this seems to be interesting. Okay, and mostly it would work. Okay, now so this is what that how the 30 is being obtained. Okay, so maybe after some point of time that you are getting 30.1, still you can go for a next value which is minus 0.05, and with that you can go to more and more closer to 30. So here always, as it is an iterative operation, iterative process, so in an iterative process always there is a trade-off between accuracy and number of iterations, that is speed versus accuracy. So that is in your hand, whatever you prefer. Now over here, just to implement this in hardware, I am just doing some sort of jumbling, okay, to have some sort of better implementation in terms of the hardware. So I can adapt some better strategy to implement it in the hardware. So this equation is standard, whatever we have seen it. I think this you know. Okay, just simply multiply crossfire and you will get the standard equation for getting a new axis x dash y dash from xy. Now over here I am putting my alpha value. Okay, and with that I am putting this di. This di is depending upon this alpha. Now I am talking this alpha. This alpha I is nothing but alpha 0, alpha 1, alpha 2, alpha 3. Now this alpha either positive or negative. Now if I apply for is a 10, then 10 is a odd function. That means tan of minus theta is equal to minus of tan theta. I hope you remember this. Okay. So tan of minus theta is ultimately minus of tan theta. So that means depending upon this alpha, whether this alpha is positive or negative, there has to be negative side which comes out from this tan. I hope you are with me. Tan is a odd function. So as it is an odd function, so whenever this alpha keeps on changing, what is this typical alpha value? Alpha 0, alpha 1, alpha 2, alpha 2. But with that alpha 1, alpha 2, it could be minus alpha 1 or it could be minus alpha 2. So depending upon that, as tan is a even function, oh sorry, tan is an odd function, this minus sign would come up. In order to take care of that, I am deciding di. So di will take care of that, whether this alpha is a positive alpha or a negative alpha. Okay. Now, here for a cos, I do not have to worry about. Why? For a cos, it can be alpha 0, minus alpha 1, minus alpha 2. But cos of minus alpha is equal to cos alpha. Why? Because it is an even function. Okay. Sine is ultimately odd function. And because of sine, that in the 10, it comes as odd. Because sine by cos. So sine is basically odd function. And because of that, the 10 becomes the odd function. But cos is a even function. So for cos, I do not have to worry about whether it is a plus alpha or minus alpha. So I do not actively worry about this sign. This will be always plus because alpha or minus alpha, it doesn't change my cos value.
Excuse me, sir. Sir.
Yes.
सर एक बार वापस DI किस लिए आया है, एक बार वापस बता दो DI.
Okay. In a previous case, what we have seen that my 5 is linear combination of alpha plus or minus alpha 0 plus or minus alpha 2 plus or minus alpha 2. If you remember, I said that always alpha 0 is positive, but this alpha 1, alpha 2, alpha 3. So any alpha beyond alpha 1 or from alpha 1 could be negative or positive. That depends upon what angle, what is your this phi value. Okay. So this alpha can be negative or positive. So here also, if I consider in general as alpha I, so let's say that for alpha 1. So if here it is minus alpha 1, then because of this minus alpha 1, what happens that you need to remember that the tan of minus alpha is nothing but minus of tan alpha. Tan of minus alpha is nothing but minus of tan alpha. Why this? Because tan is my odd function. Okay. So that means for this tan, if this alpha I value could be positive or negative, that actually reflects at the output of minus tan alpha or plus tan alpha. Okay. So that means I need to take care of over here in every iteration whether it is plus tan alpha or minus tan alpha. So in order to take care of this, I am considering di. Now this di could have a value of plus 1 or minus 1. Di could be minus 1 when this will be the case, when alpha is minus value. If it is a positive value of the alpha, then this di has to be plus 1. So this way I am actually taking care of. So this di alpha plus 1 is just to take care of this. This is di tan alpha I, just to take care of this. So this di would be negative 1 when any angle is negative. This di will be plus 1 where any angle is positive. So to just take care of this, I am getting. Now the question is कि सर आपने tan के लिए लिखा, cos के लिए क्यों नहीं लिखा? Cos is a even function. So for cos alpha or cos minus alpha, both are equal. But for a tan, as it is an odd function, it does make change because that sign would be changed. I hope I have given you the answer.
Yes, sir.
Okay. Now, here for this particular first term, I am considering this as a Ki. Alpha I, alpha 0 has to be positive because I am interested in starting in a first quarter. ठीक है, अगर अल्फा 0 की नेगेटिव वैल्यू आ गई तो वो फोर्थ क्वाड्रेंट में चला जाएगा. Okay, so initially only I mentioned that. So here that one question from the PTEC girl is that whether it is necessary to start with the alpha 0 as a positive value. The answer is yes, definitely. We need to consider alpha 0 always positive to ensure that with this we would move towards the first quadrant, and that alpha 0 cannot be greater than 90 also. So always this alpha has to be in between 0 to 90. In between any value of 0 to 19 could be possible. So that's why to just ensure that initially from x-axis I will move towards the first quadrant, I am considering alpha 0 is always positive. So afterwards alpha 1, alpha 2, for that I have flexibility. Okay. So alpha 0 has to be positive. So that's why it has to be only positive. So here it should be positive. But here it should be positive, negative, positive, negative. Okay. Now here I am considering cos alpha. See, this tan alpha I can replace with 2 raised to minus I. So in this equation, if I am interested in xi plus 1, then xi minus is initial axis. This di is also plus 1 or minus 1, that I can take care. This tan alpha I have assumed 2 raised to minus I. But the problem with this cos alpha, now as I said that कि हम सिर्फ इसको एडिशन और शिफ्टिंग से रिप्लेस करना चाहते हैं, तो दिस ट्रिगोनोमेट्रिक टर्म is creating a problem. So what I am trying to do, I am trying to consider this as a k of I. So that means I can find out k0 when k0 is cos alpha 0, k1 is cos alpha 1, k2 is cos alpha 2, like that. So this ki I am considering cos alpha 1. Now this alpha is this one. Now with this I value, if I put let's say k of 0, if I am interested in k of 0, then k of 0 must be some fixed value, because if I put 0 over here, then it is 2 raised to minus 0, which is 1. So that is tan inverse 1. Tan inverse 1 is 45. Tan inverse 1 is 45. So cos 45 is one fixed value, 1 by root 2. Okay. Similarly, if I put I equal to 1, so this k1 is also fixed 1, because when I put 2 raised to minus 1, that is 1 by 2. So tan inverse 1 by 2. So tan inverse 1 by 2 will be one angle, which is I believe 26.6. Okay. So that cos 26.6 is also one fixed value. Okay. Similarly k2 will be fixed, k3. So all the k value will be fixed. So what I will put? I will put that fixed value rather than put the cos one. Because good thing is this alpha I have fixed up by having that particular standard lookup table. That alpha value I have fixed up. So with that alpha value fixed, this cos value is also fixed. Okay. Now what I can do then? I can put one summation value of ki. K0 into K1 into K2, not summation, this is actually a product of all k. So that is K0 into K1 into K2 into K3. And if I put it up to I is equal to 9, then that K value comes out like this. If you go for I equal to 10, 11, 12, then it is making a change in the fraction bit of like this. That means 0.607252935, उसके बाद का जो डिजिट है ना वो चेंज होगा. ठीक है. So moreover, if I consider that initial 3-4 bit, then constant value is 0.60725. So that could be the k value which I need to worry over here in this particular equation. So what people can do, this you can simply neglect presently. Whenever you come up with this particular value, at end for a pre-processing, you just multiply whatever your value you are getting with this one to get the actual value of xi plus 1, yi plus 1. Because irrespective of whatever the angle, this k could be fixed. This k is nothing but the product of k0 into k1 into k2 into k3 like this. And with this k value is fixed. Now this, as it is some fixed value, I can always do some post processing. Whatever the answer that I am getting out of this, 2, that I will multiply with this to get exactly xi plus 1 and yi plus 1. This you can do it. Okay. Otherwise, what you can do, you can simply design one multiplier, and through multiplier you can get the exactly xi plus 1. Okay. But when I say that this could be done with a simple shift and add, at that time I am considering that this ki term is being neglected, and this ki multiplication I am doing of the track. ठीक है, offline I am doing this. Then and then this could be only shift and add. But if still if you want to implement it, then with the multiplication you can do it. Okay, good enough. If I can find out any particular sine cos value with this multiplication, then also I am good enough. I am good. Okay, because I know that how I efficiently I can implement the multiplication. We have seen that you can use the Wellestring multiplier or maybe Carry-Save multiplier to have some sort of efficiency during the multiplication. So this approach is very good to find out any particular angle which you require for your application. Okay. Now another thing, and good thing is this k multiplication. This multiplication you require only one, not for all iteration, because I have find out this k. This is k value. That is the multiplication of k0 into k1 into k2 into k3. So this you need to do it only once. So this you can do it. So instead of providing this ki at every iteration where you require a multiplication at every iteration, instead of that you can do it, you can multiply with this k value at the end only. So this will save you a significant time, because at every iteration to do the multiplication you require of course a multiplier, and of course it will require some time. So instead of doing that, what I can do, once I complete with all the iteration, I will multiply finally with this k. So that could be done. Now what another thing that I can do, okay, this is just for your implementation. Okay, what another thing I can do, when I am starting my rotation from 1 0, see what I am trying to do over here. I am starting to get my rotation from 1 0. Okay, and then I am rotating it, and with that this particular x term it is being multiplied. अगर आप देखोगे तो वो इक्वेशन क्या था, where this x is getting multiplied over here and over here. Okay, now what another trick that you can do, okay, instead of starting 1 0, can I start with this k value? So when I start with this k value, which is 0.637, then also ultimately I have multiplied with this particular x, because whenever I will find out next my x dash and y dash, at that time this k will be always multiplied, and that could be also taken care. But that is slightly a tedious job. Okay, so instead of doing that, the better is we will start with 1 0, and we will try to find out the linear combination of alpha, and at the end we will multiply with k. So that is the normal procedure people are following. Now ultimately I need to think about how I can generate the hardware for this. So how hardware could be made from this particular expression. So here basically what you wanted, maybe this D could be positive or this D could be negative. So for that what I am trying to do, ultimately I am finding out the difference always, and that difference I am getting, if that difference is less than 0, then I need to go for a +1. That's what I said, that if I am starting with the alpha 0, if it is a 45, then that 45 is greater than 30. So 45 minus 30 will give me the difference positive. So at that time, what I can consider, that next alpha is always negative, or it is a reverse case. Actually, I am doing 30 minus 45. Okay, that angle is 30. So 30 minus 45. No, I am right. 45, which is my present angle, and what is my desired angle, is 30. So 45 minus 30. So that means I am getting a positive difference. If I am getting a positive difference, so that is y greater than 0. So at that time, next alpha is minus. So that means this alpha I di you need to consider. Now whether this di is +1 or -1, that is being decided by this. Okay, so if the difference is less than 0, then it is +1. If difference is positive, then it is -1. ठीक है? Now, how you can implement it? So for the implementation, ultimately, this is the equation of xi. I am just going away with that k item. That k I am considering that I will do it. Okay. So this is ultimately the equation that I am looking for to be implemented. So in order to implement, this is a equation which actually takes care of my present value of alpha with my next value of alpha. So this will take care of that alpha 0, whether it is a plus alpha 1 or alpha 0, which is minus alpha 1. Okay, now just think about how I can implement these three equations. So here I require a subtraction adder. Ultimately, if you remember, subtraction is nothing but my addition only. So if I want to implement this, then this could be the hardware. X, then shift. This shift is 2 raised to item. This will be added or subtracted with y. So the term will be xi plus or minus 2 raised to I yi. This is a plus or minus, that is basically depending on your di. Okay, so xi plus or minus 2 raised to I yi, and similarly y plus or minus 2 raised to I xi. That was the equation. Okay, now actually whether you need to consider a plus alpha or minus alpha, for that this is that every time this lookup table is nothing but my alpha 0, alpha 1, alpha 2. So that standard value, alpha 0 is 45, alpha 1 is 26 point something, this is some 18 point something. Okay, like that. So these are the standard value. So every time whatever the z I am comparing with this. Okay, so initially I am starting with z is equal to 0, and then I am comparing with 45. So initially I am considering that alpha 0 will be there, and then onwards whether it is a minus or plus alpha, for that this comparator will decide. So always that I am comparing 45 minus 30, value is positive, so next value is negative, that next alpha is negative. Then if 45 minus 30 I am getting 15. So 15. Now I need to add something. Next alpha should be added so that I can go to the nearer to 30. So that means next alpha will be added. So like that, this comparator will decide that whether you need to give positive alpha or negative alpha. Okay. So this actually output you need to feed it to somewhere over here. So that is actually not being defined in the diagram, but that you need to fit it somewhere over here. Okay. So this would be the simplest implementation of my Cordic. Now over here, just one question that I am asking, that this is you have observed for alpha. Now question is angle I can definitely find it out. But if I want to find out some trigonometric function with this, then what I can do with this? So for that you need to choose your initial value of x and y accordingly then. Suppose that I want to find out sine. Okay, so for that sine, what I need to ensure that for that particular sine, this x has to be 0 and this y has to be 1. Then and then I can get this x dash which is equal to minus y sine phi. So at that time this could be omitted. So that means this xy is always in my hand. What is this xy? Xy is from where I am starting. So I can start with this point also. So at that time I can simply put x equal to 0, y equal to 1. So this term will be vanished. So at that time I could be able to find out my sine phi because this y is equal to 1. So x dash is equal to nothing but my sine phi. So cos phi अगर आपने ढूंढना है तो cos phi के लिए तो ये 10 से ही स्टार्ट करना होगा. ठीक है. So this way you can put it. So once sine and cos is available, then you can find out any trigonometric function with that. Okay. So this way, this Cordic could be useful to achieve some complex functionality where you can find out some typical angle or some trigonometric function you can use some online material. So I will share this PPT on Canvas. Otherwise, the Cordic is not there in Rabia or KK Pari. But I believe that online material is good enough. Okay, so that you can read it. So one PDF is there that I will share with you, and this PPT, just try to understand it. If you are getting any issue, let me know. We can discuss. Okay. So that's all from my side. So next time when we will meet, at that time we will now move for a KK Parhi. So KK Parhi's second chapter we will discuss. That is the iteration bound. Okay. So from next time onwards, I will cover the content of KK Parhi. I will mainly interested in talking about from second chapter onwards. First chapter is just an introduction why VLSI DSP systems are required. So that if you want, then you can read it out. But the main content we would like to start with the chapter second. Okay. So chapter 2, 3, 4, 5, 6, 7 that we need to discuss for from KK Parhi. Okay. Yes, any doubt?
Sir, excuse me, sir.
Yes.
Sir, some of us are having doubts in linear carry select adder, sir.
Okay.
Can we have a session about that later on?
Maybe we can discuss. Maybe we can have a meeting one-to-one through call, or maybe we can have a this Microsoft Teams meet. So over there we can discuss. No issue.
Okay. Okay. Thank you, sir.
Okay. Okay. So that's all from MTech. So just I am disconnecting now. Maybe I can take the attendance. Okay. So now